Your child came home from school today asking for help with math homework, and you see it's about fractions. That's not hard enough, but all of a sudden they're talking about fractions and tiles, and you're not sure what to do with it. All right, so today I'm going to respond to a comment that came up in one of the videos I posted previously about solving some fraction work with fraction tiles. And one of the viewers said, hey, that's neat and all, but can you divide 1/2 by 3/5 just by using tiles? So today I'm challenging myself to do just that. I want to see, can we do fraction division using just tiles? And then, of course, you know I'm going to try and relate that back to an equation. But let's see if we can do 1/2 divided by 3/5 just using tiles without using any kind of math rules we're thinking about. So to do that, I have my 1/2 here, and I have my 3/5. So 1/2 divided by 3/5. And for the sake of discussion today, I'm going to think about division, meaning how many of one thing fits into another thing. So 1/2 divided by 3/5 is asking the question, how many sets of 3/5 fit into 1/2? And as you can see right now, if I'm looking at the tiles, I can actually see that it's actually not even one full group of 3/5. So how many of these fit into 1/2? They're actually larger than 1/2. Therefore, it's actually going to be a fractional number when we come up with this, is a full set of 3/5 does not fit into 1/2. So to help me make sense of this, I'm going to change the fraction tile size so we can begin to do some different ideas with this. And here I'm going to use tenths, and the reason I'm using tenths is because I know that that's a fraction that will fit perfectly to align to fifths, and it'll fit perfectly to align to halves as I look into this. So I can see that it's going to be 1, 2, 3, 4, 5, 6 tenths. 6 tenths equals 3/5, and 1, 2, 3, 4, 5 tenths equals 1/2. And that's going to help me to visualize, to compare when I'm looking at that same whole. And sometimes I do like to kind of come back into here and say, hey, let's look at the whole and say, okay, how does that fit into here, and some of those processes. But I do want to compare to the same whole, the same size fraction tiles, which is why I like fraction tiles, because they're all based on the same size whole. This is half, this is a fifth, this is a tenth of the same size whole we're looking at here. For the sake of me thinking through this, I'm going to go ahead and remove the actual fifths right now, and I have renamed them as tenths. So it's the same exact value. I'm just not calling them fifths, now I'm calling them tenths. So how many of these full sets fit into a half? Well, if I think about it in this way, it's not a full set, it's part of a full set. So what part of a full set of 3/5 fits into 1/2? Let's see, 1, 2, 3, 4, 5 of the 6 tiles that represents 3/5. So in fact, I just solved the problem. I can think about this and I can say 1/2 divided by 3/5. We renamed 3/5 as 6 tenths so that I can see them and compare them perfectly to 1/2. But when I think about this, it's not one full set of 3/5. In fact, it's going to be 1, 2, 3, 4, 5. 5 of the original 6 tiles that was my full set. So 1/2 divided by 3/5 equals 5/6. So I do want to bring back that standard algorithm that we're thinking about, and I want to see, does the standard algorithm give me the same value? So I'm going to set this off to the side for a minute, and I'm going to think about 1/2. So here's 1/2 divided by 3/5. And many of us learned a rule that to divide by a fraction, we multiply by the reciprocal. I have heard some folks say keep, change, flip. I know there's some debate about whether that's something we want to teach kids or not, but basically we're thinking about the rule is to divide by a fraction, multiply by its reciprocal, and then I multiply the numerator times the numerator and the denominator times the denominator, and I end up getting 5/6, which is the exact same value that I got with my tiles. Now, I know many people are going to think, hey, why don't I just use the rule every time? It's way faster, it's way easier, it's way quicker. And I would say, yes, I agree, it is way faster and way quicker, but it doesn't really help me understand what's happening when I'm thinking about fraction division. And it's not always about getting the answer quickest. It's sometimes about understanding what does it actually mean. And a challenge I have for everyone is we just did the rule, and I also talked about using the tiles and thinking about 1/5, changing that to tenths. Why does the rule work? Why does that multiply by the reciprocal work? Is there a way I can explain that without just saying it's the rule, it works? Is there a way I can explain that with fraction tiles? Is there a way I can explain that with contextual understanding? If you have a great way of explaining why the rule works without just saying it works because that's the rule, go ahead and throw it in the comments. I am always interested to hear how different people make sense of some of the rules we have in math, and if we can make sense of it, we really understand it.